this is two problems that have to do with equivalence. Equivalents are a way to match up charges. For example, if you have a cell wall and you have a sodium ion that leaves that cell wall, the cell will try to maintain neutrality. It could have a chloride ion that would go out, but if a calcium ion came in, you'd actually have to have a second sodium ion go out to match up with that. And that's where the idea of equivalence comes from. Equivalents have to do with charge, so it's like the number of charges per ion. So if we were 0.02, if we had 0.02 moles of carbonate ion, there are 2 equivalents per mole, so we would have a total of 0.4 equivalents of the carbonate ion. And that means that to match up with that, you would have to have 0.04 equivalents of sodium ions, which is the same as 0.04 moles of sodium, or 0.04 equivalents of calcium plus 2, which is the same as 0.02 moles of calcium plus 2, because each calcium has 2 equivalents with it. I think equivalents are actually fairly important in medicine, and nurses probably don't get into this a lot. Physicians probably do, but I believe that you will see on some blood work, you will see things that will be in equivalents or milliequivalents per liter. So the next problem tells that you have 0.633 grams of calcium plus 2, and it's in 850 milliliters. I'm immediately going to shift that into liters because my answer is asking me for equivalents per liter or milliequivalents per liter. As with the previous problem, I know that there are 2 equivalents in every calcium plus 2 ion, but actually I'm not ready for that yet, and hopefully you caught why. I need to change those grams into moles, because this time it's given in grams, and calcium plus 2 ions have the same molar mass as elemental calcium does. There are 40 grams per mole. Again, if you're doing a problem, you should pick your molar mass from your textbook. I shortened it to the 40 that I know in my head. And now I know that there are 2 equivalents per mole for calcium because calcium has a plus 2 charge. So this will give me my equivalents per liter. I'll take 6.33, multiply it times 2, divided by 0.85 equals, and then divided by 40. And I got 0.37 equivalents per liter. And if I wanted to convert that into milliequivalents, I'd move the decimal 3 places, and it would be 0.37 milliequivalents per liter. So this is an example of doing problems with equivalents.